In this video, we're going to talk about present value for compound interest. Now, normally with compound interest problems, we're given an initial amount of money and we're given the interest rate per period and we're given the total number of periods and we're asked to calculate the future amount. So remember, the formula was A is equal to P times 1 plus I to the N. So in other words, if we know P and I and N, we can find A, the amount in the future. Well, with present value problems, it's just the opposite. We know the amount that we have in the future, okay, and we also know the interest rate and the number of compound periods, but we're trying to find the P. Okay, so basically instead of knowing P and we're trying to find A, we know A and we're trying to find P. So basically we want to solve this for P. How would we do it? Well, if we want P all by itself, we divide both sides by 1 plus I to the N. Okay, both sides of this equation, 1 plus I to the N. Notice these would cancel over here, and we'd be left with P is equal to A over 1 plus I to the N. Okay, and this is the present value formula for compound interest. So notice that's what I've written down here. The present value of $A compounded at an interest rate I per period for N periods is given by this formula. Now ultimately, this came from this formula, just the formula for compound interest, okay, but we divided both sides by 1 plus I to the N. Okay, so let's look at an example. It says find the present value of $13,000 in 5 years if money can be deposited at 9% interest compounded monthly. Now, let's think about this for a second. Do we expect our final answer to be more than 13,000 or less than 13,000? Okay, now this 13,000 represents the amount that we have in the future, okay, 5 years from now. Okay, so $13,000 5 years from now is really equivalent to how much right now? Well, I would expect it to be less than 13,000. In fact, if we start plugging things into our formula, we have P equals A over 1 plus I to the N. The I is what? Well, the I is 0.09 divided by 12 because we're compounding monthly. Okay, 9% interest compounded monthly, and I believe this is 0.0075. Okay, the N, what is the N? Well, we're compounding monthly for 5 years. Okay, so 12 times a year for 5 years, so that'd be 12 times 5. That would be 60. Okay, now what about the A and what about the P? Well, the P is the present value. That's what we're trying to find, the present value of the principal. The A is the amount in the future, and we're told that that is $13,000. So let's plug things in. We have 13,000. Okay, it's the future amount. Over 1.0075 to the 60th power. Okay, so again, we would definitely need to type this in our calculator. And I got $8,303, and rounded to the nearest penny, it would be 10 cents. Okay, it was actually 8,303.096. Okay, but round to the nearest penny, it'd be $8,303.10. Notice that is less than 13,000. So what this is essentially saying is that $8,303.10 right now, if you were to invest it in this account where you're getting 9% interest compounded monthly for 5 years, then at the end of that 5 years it would be worth 13,000. So 8,303, that's the present value of this $13,000 in the future. Now, I should mention that a couple of the problems in my math lab, at least one of them anyway, doesn't actually use the word present value anywhere in the problem, but it'll have a problem where it says something like, how much would you need to invest right now in order that, say 7 years from now you have $25,000 if you can invest it at a certain interest rate, compounded a certain number of times per year. But you have to realize that's a present value problem, right? You're trying to figure out how much do you need to have now, how much do you need to invest now to have a certain amount in the future. That would be a present value problem.